Hey everybody, welcome back to our second video for lesson 2.3 where we're continuing to play with that addition rule. Remember, anytime that you use the word or, I need to add my probabilities together and check for an overlap. So example 4, there are 8 people in the room, 4 men and 4 women. 2 of the men and 2 of the women are planning to go into the medical field, while the other 2 men and 2 women are planning to go into process technology. If you select one person at random from this room, what's the probability that you will select either a woman or a person in process tech? Now they just gave us a lot. They told me men versus women. Okay, I'm going to go ahead and organize this in a table for us just to kind of help us see what's going on. They also told us process technology versus medical. So they tell me there are 4 total men in the room and 4 total women for 8 people in all. But then they tell me 2 of the men and 2 of the women are going into the medical field. So 2 men and 2 women are going into the medical field. Then they tell me 2 men and 2 women are going into process technology. So sometimes trying to sketch out a little table to organize what the words mean can be helpful. Now it says if you select one person at random, what's the probability of selecting a woman? I'm going to use W, or someone going into process technology. I'm going to use PT for that. So the or probability says take your women, add that to your process technologies. Let me write that a little cleaner for us. And subtract any overlap. So what I'm looking for is the probability of being a woman and being in process tech, aka women in process technology. Don't confuse this and with what we were doing in our last lesson. In lesson 2.2, we were looking at 2 completely separate events, a coin and a card, or a woman and another woman. This use of the word and is saying, hey, I want to be a woman and a process technology in a single event, in a single person. So just be careful. There is a distinction there. If I'm first just looking at the probability of being a woman, there are 4 women, 4 total women in the room out of the 8. Then I look at just process technology. It tells me here that there are 2 men and 2 women in all going into process technology. Well, right now, PT, process tech, I'm just looking for the fact that there are 4 people in all going into that industry. However, when we did that, we just double counted these 2 people. When we looked at our women and we looked at our process technology, we double counted the 2 women in process tech. So they didn't magically grow twins. I have to subtract or remove that overlap back out. Common denominator stays common, so don't reduce. And then I add up. 4 plus 4 is 8, minus 2 is 6. Giving me a fraction of 3/4, or 0.75. 75% shot of selecting somebody at random and getting a woman or someone in process technology. Now you might have noticed I kind of pushed us towards setting up that table because it's one way that we can organize our data to keep it cleaner or easier to look at. Sometimes the problems will be nice enough to go ahead and set it up that way for us. So example 5. Suppose that after a vote in the U.S. Senate on a proposed health care bill, the following table shows the breakdown of the votes by party. Please, by all means, this is not a political statement. This is just another situation where we can look at probability. Statistics are all over our world, especially in politics, but this is not a political statement. If a lobbyist stops at a random senator after the vote, what is the probability that the senator either will be a Republican or voted against the bill? So the probability of being Republican or against. I get to split this up into just looking at my Republicans as its own separate event, or tells me to add that to the probability of being against as its own separate event. But I always have to subtract the overlap. This is where I'm looking for Republican and being against in the same person. So for my Republicans, the probability of being Republican, there were 50 of those. Hold on, before we get there, I need a total. My total in the entire table, if they don't give it to you, you just stop and add up all the categories. 23, 21, 43, 7, 2, and 4. So 23 plus 21 plus 43 plus 7 plus 2 plus 4. There are 100 people accounted for in this total. So that means there were 50 out of 100 Republicans. 50 Republicans out of 100 total. Now I'm going to add that to looking at just the people who were against the bill. So I look at all against as if it's its own event. 21 plus 7 plus 4 should be 32. If you're not sure, add them up. 21 plus 7 plus 4. 32 people. The problem is when I did that, there were 7 people that were counted as the Republican and then counted again because they voted against. Well, those 7 people did not magically grow a twin, but right now they're counting twice. So I need to subtract that overlap back out. Common denominator stays common. Add or subtract across the top. I have 50 plus 32 minus 7, giving me 75 out of 100. That can reduce to 3/4 or 0.75. Now, these last several of examples have all had overlaps in them. But keep in mind, sometimes there won't be one, and that's okay. Let's do one more of these from the Senate. If a lobbyist stops a random senator after the vote, what is the probability that the senator will not be classified as independent or did not vote in favor of the bill? Whew. That's a lot. I will tell you, setting this up as a complement really might not be helpful. Let's just take it one step at a time. If I'm looking for not independent or not in favor, stop and translate that. If I'm not in favor, what does that mean? It means I'm against. Right? If I'm not in favor of the bill, that means I'm against it. So when I look at the probability of not independent, what I'm asking you to give me are the Democratic and Republican people. Now, if I am not independent, it might be easier here to take my 100 people and remove the 6 that were independent. That's where that complement rule could come in handy. If I'm looking at not being independent, take your total of the 100 and remove the 6 independents, giving you 94 out of 100. But then the formula says or, so I add that to the probability of being against. So my against, we looked at that in the last example, those were 32 out of 100. If you tried to stop right there, notice you have more than 100 people. Something's wrong because there's only 100 people in this entire example. So when I had my Democratic Republicans, and then I came in with my against, who got double counted? That would be these. If they're giving you a table like this, highlight, circle, do whatever you need to do to notice that there were 28 people that got double counted out of the 100. So common denominator stays common. Add across the top, subtract your 28. 98 out of 100. Remember, if you're not sure on simplifying, you can do this in the calculator. Math fraction, 49 out of 50. Or 0.98. You can also give it as a decimal. All right, we have 2 more examples. Example 6. The frequency distribution shows volumes of sales and the number of months in which a sales representative reached each sales level during the past 3 years. Using this sales pattern, find the probability that the sales representative will sell between 0 and $49,999 next month. Now, this is just kind of taking us back to the fact that these and or probabilities, we're really just combining our events, our options here. If I want to know the probability of being between 0 and 49,999, notice that requires me to take the probability of being between 0 and 24,999 and adding it to the next group. The probability, hold on, let me make this a little shorter here for us. The probability between 0, 49 is broken up into 2 groups. 0 to the 24,999 and the next group from 25 to 49,999. But y'all, you don't always have to set it up like a probability. You can just combine them by adding up. 3 plus 5 is 8 people were in those categories out of your total. So don't overlook or get so bent on the formulas that you lose sight of what it's just asking you for. It wants this group or that group, add your 2 groups together. So right now on the screen, what I'm doing is I'm finding out my total. 3 plus 5 plus 6 plus 7, 9, 2, 3, and 1. There were 36, 8 out of 36. The reason I'm able to do this is because there was no overlap. to be concerned with. If there's no overlap, no duplicates, you can just add your groups up and be done. It's only when there's those duplicates, those overlaps, that you have to really remember to subtract out or follow the formula. So 8 out of 36, I can divide that by 4 to reduce it. 2 out of 9. Right, 8 divided by 36 as a decimal, 0.22. All right, one last example. Example 7. Find the probability of rolling a sum of 3 or 4 when you roll 2 6-sided die. Ooh, well, that's the first time we've seen that. When they're talking about 2 6-sided die, I highly, highly recommend you make a dice table. A dice table allows us to look at my 2 dice. The first one having 1 through 6 as a result. The second one having 1 through 6 as a result. And this is a way for us to look at the outcomes of both dice. The probability is specifically asking me to roll the sum, meaning it's asking me to set up my table. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. So if I use my table to look at my outcomes, I can add my dice together. So go ahead and keep adding. 2 plus 1 here is 3. 2 plus 2, 2 plus 3, 2 plus 4. I'm going to go ahead and finish out this table. I encourage you to do the same. So what this table is telling us is that the largest outcome that I can get, the largest one would be the number 12, right? The biggest sum I can get is 6 plus 6. But I have a total number of outcomes of 36 if I stopped and counted each of these up. So when it asks me for the probability of a sum that is 3 or 4, y'all please draw this dice table. Please stop and sketch out the answers. It will be easier for you. So I can look at just the probability of rolling a 3, a sum of 3. Well, the 3 shows up in my list 2 out of the 36 times. Or it tells me to then add that to the probability of rolling a 4. Well, the 4 shows up 3 times in my list. Is there any overlap? Well, no. Notice that 3 and 4 are separate results. There's no overlap. I can simply add. 2 plus 3 is 5 out of 36 results. And you get to stop right there. When things are mutually exclusive, you can simply add them up. There were 1, 2, 3, 4, 5 outcomes in my sum table that gave me what I wanted. Well, I ran this video long, but it is the last video for this lesson. Work on your homework. Bring me your questions. We will continue the conversation of probability in our next set of videos.